In this video, we're going to discuss how to solve equations with rational exponents. Before we do that, we're going to do a quick review of what inverses are. So if I said to multiply by the inverse of 4/3, the inverse of 4/3 would be 3/4. The inverse of 2/3 would be 3/2. The inverse of 1/4 would be 4/1, or just 4. The inverse of negative 5/1 would be 1/-5. So for the inverse, it's just like taking the reciprocal. Another notation that we need to review is how to go in between rational exponents and radicals. So 9 to the exponent 1/2 is the same thing as 9 the square root of 9. 81 to the exponent 2/3 is the same thing as the cube root of 81 squared. 4 to the exponent 1/5 is the same thing as 4, the 5th root of 4 to the 1st. Right? Because this 1 here, whatever is on top of the numerator, goes here, right? And then on the denominator of 2, remember, for square root, you can have an invisible 2, or you can write a 2 there. And same thing goes here. So 81 to the exponent 2/3, this 2 is this 2, and this 3 here is this 3 here. And same thing with the last one. The 1 here is this 1, and the 5 on the bottom is this 5 here on the outside of the radical. What we want to do in order to solve for number 1 is to get the x to the 3/2 to be x to the 1st. So what we're going to do is we're going to multiply 3/2 by its inverse to both sides of the equation. What happens is that this 3 cancels out with this 3, and that this 2 cancels out with this 2 here. So we're left with x equals 27 to the exponents, we'll put it in different colors here, 2 and 3. But remember that 2/3, if we have 2 divided by 3, is the same thing as 1/3 times 2. So you can always keep the denominator of 3, put a 1 on top, and multiply it by 2. So for this equation, we can write x equals 27 to the exponent 1/3 squared. So now I have to figure out what is 27 to the 1/3. Well, this 3 on the bottom says that we need to multiply the same number by itself 3 times to give us 27. So something times something times something equals 27. And that number is going to be 3. Right? 3 times 3 times 3 is 27. So how many of these 3's do we take? We're going to take just one of these 3's. So 27 to the exponent 1/3 is going to be 3. So we have x equals, in parentheses, 3 and squared. 3 squared is equal to 9. So we'll get x equals 9. So we have to figure out, all right, does this check? In order to check our work, we're going to substitute this 9 in for this x. So it's going to be 9 to the exponent 3 halves. Does that equal, put a question mark, 27? Remember, 9 to the exponent 3 halves can be written as 9 to the 1 half cubed. Does that equal 27? Well, what is 9 to the exponent 1 half? This 2 tells us that we need two numbers to be multiplied together to give us 9, two of the same numbers. And that's 3. 3 times 3. And then this number on top in the numerator tells us how many of those 3's do we take. We take 1, 3. So 9 to the exponent 1 half is 3. 3 squared. 3 cubed. Does that equal 27? 3 cubed is 3 times 3 times 3. So we have 27 equals 27, so that checks. We'll look at number 3 next, because I know some of you guys have fought off the fear of fractions, and especially negative fractions. So we're going to do the same thing though. We're going to multiply by the inverse of negative 3 halves. So we're going to multiply by 2 over negative 3. So see how this negative right here is on the side? That means that you can either put the negative on the numerator or the denominator, but not both. So we're going to multiply to the 2 to the negative 3 here as well. So what happens is this negative 3 cancels out with this negative 3, and this 2 cancels out with this 2. So we're left with just x equals 1 over 729 to the exponent 2 over negative 3. So, quick reminder, if we have 4 to the exponent negative 1, that's equal to just 1 over 4 to the first. 4 to the negative 2 is equal to 1 over 4 squared, or 16. And we can keep going. 4 to the negative 3 is equal to 1 over 4 cubed, or 4 times 4 times 4, or 64. So in order to make a negative exponent become positive, you take the reciprocal of the base. So the reciprocal of 4 would be 1 over 4. In this case, we have 1 over 729. The reciprocal of that would be 729 over 1, or just 729. And that would create a positive 2/3. From here we solve it just like we did the last problem. We can rewrite this as 729 to the exponent 1/3 squared. So remember, whatever's in the denominator will go in the inside, and whatever the numerator is will go on the outside. So we have to think about three numbers, three of the same numbers that multiply together to get 729. Right? So that's something times something times something is equal to 729. That number is 9. And then how many of those numbers, right? Because there's three numbers that multiply themselves to get 9. How many of those numbers do we want to keep? We want to keep just one of them. So it's just going to be 9. So this is going to be x equals 9 squared, which is 81. And you could check your work the same way we did number 1. For number 4, this time we have a negative in front of the base. We want it to be positive x to the first. So we want to take the inverse first of multiplying its negative 1 times x. So we take the inverse of multiplication, which is division. We want to divide by negative 1 on both sides. And we're left with just x to the exponent 1/3 equals negative 4. We take the reciprocal, or the inverse of 1/3, which is 3 to the first, to both sides of the equation. this 1 cancels out with this 1, this 3 cancels out with this 3, and now we're left with just x alone. And negative 4 cubed. So it's negative 4 times negative 4 times negative 4, and that's going to be equal to negative 64. In the last problem that we did, it looked like this in red. But what is the difference between that red equation and this blue equation? It looks like the only difference is this minus 0. But what is x minus 0? X minus 0 is just x, right? 5 minus 0 is 5, 7 minus 0 is 7, and so on. Right? So the blue equation and the red equation are actually the same thing. The reason I bring that up is because in this problem, we want to isolate 65 minus n to the exponent 3/2, just like we did in the last problem. We isolated the x to the exponent 1/3. So first step we're going to do is subtract 2 to both sides of the equation. Negative 646 minus 2 is negative 648 equals negative 3 times 65 minus n to the exponent 3/2. And then we're going to divide by negative 3. Negative 648 divided by negative 3 is 216. And that will be equal to 65 minus n to the exponent 3/2. So now we have isolated whatever's in the parentheses and the exponent. So we can solve it the same way that we did the previous problems. Take the reciprocal of 3/2, which is 2/3. Sorry, the inverse, I should say. So we're going to multiply 2/3 to both sides of the equation. And then this 3 is going to cancel out with this 3, and this 2 is going to cancel out with this 2. So we're left with 65 minus n equals 216 to the exponent 2/3. And we can rewrite that exponent as 216 1/3 squared equals 65 minus n. The cube root of 216 is 6. 6 times 6 times 6 is 216. And then we take one of those 6's. So 6 squared equals 65 minus n. 6 squared is 36. If you subtract 65 from both sides of the equation, you get 36 minus 65 is negative 29 equals negative n, and the last step is to divide by negative 1. So n will be equal to positive 29, and you can check your work by substituting 29 in for n.